Now, for those, this is where the enhancement comes in, right? Because we're taking that GF320 and mounting it on top, 30 to 40 feet in the air, pointed down from an optimal position where we can see the equipment. And so far, on we've been able to cover every upstream site we've been on, cover all the important equipment with one single OGI. And the other thing that we do is then we allow the users to define zones, okay? And this is what it allows them to do is really get down to the equipment level. And so we're getting smarter and smarter about certain equipment. We even include exclusion zones, and then we can allow us to measure down the equipment level, and it provides all that metadata saying this alert was on this site with this piece of equipment at this duration of a leak and this quantification. So it really allows you to do some amazing remote diagnosis.
I think an incredible benefit of what you're seeing there from an operational standpoint is that the user doesn't have to be as active on the back end of the video, right? Watching, differentiating. When you
Right.
have a zone that defines what's important within each zone operationally, then the team can sort of let the video system really do its work, and they don't have to have someone behind the screen delineating what's what. So that's a huge difference maker.
And from the beginning, our operators said, okay, take these sensors, these cameras, and again, I'll show you some other ones. We have the OGI FLIR thermal camera. We even have optical cameras and microphones. They all run through an edge device. So this runs on the edge, and it will even run if we lose internet connection, people ask. So it runs on the edge. We then translate all that video data into telemetry data that goes across MQTT or Modbus over to their SCADA system and goes up to SCADA. So you can get alerts for all the stuff that we do right in their SCADA system, the UI that they're used to looking at. But in addition, we do send data up to our platform and allow the operator to configure their system using our dashboard, which you just saw, okay? And that allows you to really dial in those alerts. But again, you can receive those alerts right through your SCADA system, fully integrated. Now, where we sit in terms of other leak detection solutions, so the EPA is down here. EPA says you got to get in there and look at each component. And with some of the new subpart W, they're really specifying, I want you to look at this piece of equipment, this piece of equipment. Same thing with OGMP 2.0, the Oil and Gas Methane Partnership, where level 4 says you got to do source level emission quantification. So that's where the source level's at. Now, some other sensors, they do site level, so they can't see anything, but they're high frequency, they're continuous, and they say at a site, we detect something, but we don't know what the equipment is. Planes fly over, and they see a much higher level, but a lower frequency. Maybe they only fly over a few times a year. And then, of course, satellites, which I've seen some satellite images where the entire site is a single pixel and very low detail. CleanConnect sits down here, so we can do site, source, and component level quantification. So detect and quantify down at the equipment level, which is where it's all going with EPA, OGMP, and whatnot. And in fact, we are now in beta testing where we could go on a brand new site, the camera will move around and literally detect equipment for you so that it can build models around specific things. Because as any operator will tell you, each piece of equipment has a certain behavior that's normal and then abnormal. Well, our system knows the difference. Now, what about, some people say, well, wait, can't I do continuous monitoring with sensors? Okay, well, we had an actual client provide us this data where they had both sensors running on fence line monitors, okay? And then they had our continuous system. So the wind was blowing in different directions, and we could see all this kind of stuff. But we at CleanConnect, we say seeing is believing, because here's what we see, okay? So we literally see the leak happening, or in this case, a blowdown event. We're seeing it. You can see the computer vision model identifying it, sending alerts, and quantifying it on the fly. Okay, so the wind is blowing in this direction. You'll see it shift to another direction. What's interesting is the sensor is right here. Okay, so here's the data that came from the sensor. It didn't even make to the 1 part per million. And by the way, this is the regulatory limit. You got to alert at 1 part per million, but it didn't even see it. So it didn't even go off. So on one hand, we're sending alerts. Our client's able to see this video and go, oh, I see what the thing is. I know what to do with it, right? I mean, easily you can remotely diagnose this. The PID sensor didn't even go off. So they had to look at the data and try to figure out, why didn't it go off? Clearly the wind's blowing. I mean, it's blowing. Why didn't it go off? So it really kind of brings into question the entire, like if you're certifying based on PID sensor data, you really need to look at that, okay? Because this is going to get out there, right? Now, not only do we have to do this with our clients, which is the biggest test, but we had to go through the toughest certification process possible called CDPHE AIM 2.0. Colorado required proving equivalency with monthly and continuous manual LDAR operator with a handheld GF320 using LDAR SIM modeling, which is an accepted modeling system. It requires using an approved OGI camera, which the G300A is. We essentially had to pass a Turing test. We had to prove that our computer vision AI replaces a human being with a handheld camera doing monthly. And now with Reg 7, any new site after a certain point, 10 days before drilling all the way through 6 months of production, you have to show continuous monitoring, okay? You must document actual automated LDAR work practice and demonstrate how you will detect, diagnose, and fix any problem. And here's the cool thing. They actually encourage, if you can detect it and fix it remotely, that's acceptable and encouraged. You have to have a Colorado operator agree to the entire AIM application, this whole process, with actual production field experience. So we had to literally turn in a year's worth of data in our application. You must demonstrate detection with blind testing limits, and it must be reviewed and approved by the EPA. We're now on number 7. So we've done 1 through 6. We're now being reviewed by the EPA. This is an actual LDAR.
Mark, if you want to go back to AIM 2.0 for a second, just to kind of highlight like where things have, how far things have come, related to this type of technology, like having been involved in passing AIM 1.0, if you will, and seeing how CDPHE has adopted and, made some changes based on learning experiences. The fact that they're requiring an operator to agree to the application, thinking about how the work practice and how you'll detect, diagnose, and fix any problems found. This is a great adaptation of the learning experience, right? Having passed AIM 1.0, I know we didn't know what we didn't know at the time. And now CDPHE has sort of brought this whole thing in where they're really thinking about how it's going to be used in the field. And I think, this is really cool. It just shows that when you pass AIM 2.0, the solution is really not just ready to be implemented, but it's been implemented and it's proven. So,
right. And you're getting an operator. The big thing on this side, number 4, think about what that operator is agreeing to do. So if the regulatory says you find a leak, now you got 30 days to fix it, and even some fudge factor, these operators are saying, if I find it, I got to start working on the repair immediately. Mm-hmm. Okay. Now, as it turns out, since 80% is production, they actually do want to fix it anyway, because they know if I can recover that production, like a separator not working because a pilot light went out, or a tank not doing what it's supposed to, or an ECD going off, and literally will show you, it's not operating correctly. If they fix it immediately, they can capture that gas that would otherwise just go into the air. And in Colorado, why are the rules so strict? These guys know, if you've been out to a site, most of these sites are within 1,500 feet of a community. So when something breaks, you don't want your leak detection to be a homeowner calling a regulator or the fire department saying, hey, the oil and gas site's on fire, right? You want to be able to get all over it. Now, here's where we came up with LDAR SIM. So here's, if you do nothing, the red line. The blue line says, okay, here's what monthly would look like in terms of emission reduction that you're catching, and here's where Clean Connect is, right? So we're better than a guy with a doing monthly inspection, okay, as you would expect for a continuous solution. Now, here's what we found after doing 2 years of autonomous LDAR. The benefits: 80% of leaks are caused by production equipment failure in tanks and combustion devices. So we're seeing the same thing over and over again. And if repaired quickly, customers can recover 3% of production. Some have done more, but I'll just give you that number. Their ability to repair 80% of it remotely. So they can see it, they can diagnose it, and in many cases, just fix it remotely. Saves the windshield time. Enables management by exception, eliminates 80% of the call outs. Here's a little math. Colorado, because of the frequency of required inspections, they have 682,000 scheduled call outs. Somebody getting in a truck, driving out, doing this inspection and getting back in the car. 80% reduction would eliminate 545,600 callouts, which would nearly eliminate the number one safety hazard, which is truck accidents to and from a facility. We do believe, because we're seeing the same pattern over and over again, that within a few years, we're going to be able to detect and repair most leaks fully autonomously. Okay, right now, it's on the leak detection side, it is autonomous. On the repair side, it is AI augmented. Again, it's allowing people to do remote monitoring and management.